Let knowledge flow like a river without any hindrance. Don't make it like a stagnant pool. Question and answer. Hello everybody, I'm PS Chatterjee with you. Today I'm going to clarify a few good questions raised by Mr. T. Narayan Murthy regarding the design of combined footing with 3 columns. Serial number 7R. It is my great privilege that Mr. Murthy gave me a chance to open my heart more broadly and also gave me his permission to publish his name in this lecture. According to me, the question raised by Mr. Murthy are the question of many other designers. First, I am going to introduce Mr. T. Narayan Murthy with you. Mr. T. Narayan Murthy, Superintending Engineer of Andhra Pradesh Power Generation Corporation. This is the letter I have received from Mr. T. Narayan Murthy. He asked mainly 2 questions. First question, how can we introduce more load case in the same format to generalize the program? Second question, why I have used the center to center distance between the column instead of taking the effective length. Before start of the lecture, please like, share, and subscribe my channel. My opinion and codal provision. Regarding first question, I should say, yes, we can put more load case in the same format, and how we can put more load case, that I'm going to demonstrate after answering the second question, which is more interesting and controversial question in the world of structural design. Answer of the second question. That is why I have used center to center distance between the 2 columns instead of considering the effective length. Load transfer from column to isolated footing or combined footing without strip beam. For isolated footing or combined footing without strip beam, the load from the column will be released on the top of the footing slab. Calculation for two-way shear check. This is the cross section of a footing. When the load is releasing at the top of the footing, it will distribute at an angle 45 degree in both directions. In this figure, I have denoted this by red colored zone, and it is a highly compressed zone. Length of this portion from column face is equal to the depth of the slab at column face, that is D, in both directions. For the calculation of two-way shear force, we have to consider the average length of the inclined portion, and it will be equal to a cube, and area will be 2 into D plus A plus 2 into D plus B, where A and B dimension of the column, and punching area A punch is equal to D into 2 into D plus A plus 2 into D plus B. Punching stress for two-way shear stress tau V1 is equal to Fs into P into A punch, and this tau V1 should be less than equal to tau C minimum, and the value of tau C minimum is equal to 0.25 square root of FCK. Fs is equal to factor of safety. Tau C minimum not dependent to the percentage of steel provided, but the dependent to the grade of concrete. Actually, this stress is axially compressive stress. Calculation for one-way shear and bending moments. For one-way shear and bending moment, we have to consider the length LC, that is LC is equal to L minus D divided by 2 minus D. And the depth of the slab at LC is equal to DC is equal to LC plus D minus DF divided by L by 2 minus B into LC. Factored one-way shear per meter is equal to tau V2 is equal to F into S into W into LC. Factored bending moment per meter width is equal to mu is equal to F into S into W into LC square divided by 2, where W is equal to upward uniformly distributed reaction, Fs is equal to factor of safety. The load transfer from column to combined footing with strip beam. For combined footing with strip beam, load from the column will release on the top of the strip beam and beam will distribute on the soil along with foundation slab. Action of this type of footing is similar to the action of inverted T-beam, and this T-beam will distribute the load directly onto the soil. So considering the slab depth at a distance d is not required. Load transmission within strip beam. This is the longitudinal elevation of the combined footing. Once again, in my combined footing design, I have considered the center to center distance between two columns. That is distance L. For the calculation of bending moment and shear force, as per theory, we can consider the effective length LEF instead of L. LEF is equal to L minus B1 plus B2 divided by 2 minus 2D. It is true that if we consider LEF instead of L, it will provide more economical design, while D is equal to effective depth. One way shear stress is partially dependent on percentage of tensile steel. Advantages and disadvantages of L over LEF. In my combined footing design, I have considered center to center distance between two columns, that is distance L, for the calculation of bending moment and shear force. As per the theory, we can consider the effective length LEF instead of L, where L is equal to center distance. L effective is equal to L minus V1 plus V2 divided by 2 minus 2D, where D is equal to effective depth. It is true, if we consider effective length instead of center to center distance between two columns, it will produce more economical design. Any design work is not a clerical job. Lot of other cofactors have to be considered during the design, and these cofactors are as follows. Importance of the structure. If it is an important structure, then using L instead of LEF is better option. 2. Service life of the structure. If we consider service life of the structure less than 50 years, then using L effective instead of center to center distance is better option. Section and orientation of the column. If section and orientation of the column are same, it is better to use LEF instead of L. Importance of foundation. Foundation is the most important part of the structure. Regular maintenance is not possible. If we consider this fact, then it will be more rational to use L over LEF. Considering L over LEF is a mistake. This mistake will be in the safe side, and I think according to the code, it is a preferable mistake. Design shear stress K tau C, where K depends on the depth of the section, and we know value for K for any beam is equal to 1. So we are not getting any advantage of K for the design of strip beam. By small adjustment of stirrup, we can get the big advantage over the shear stress. And this is my observation. Now the choice is in the hand of designer. Now I am switching over to the Excel spreadsheet for question number 1, that is introduction of more load case in the same format. Welcome to my Excel spreadsheet for the design of a combined footing of 3 columns with a strip beam. Now I'm going to give the answer of first question of Mr. T. Narayan Murthy. As per the question, how we can introduce more load case in the same format. So first select below 102 load case. Then say we required more 3 load case. Then select 17, 18, 19 and then right click your mouse. Then insert three rows created here. Now we have to do one thing, nothing to do here, but we have to copy this 102. Remember that 102, not 101. Now copy this. Okay. Now say our load case is this one. Put here, paste spatial value. Once again, say I'm taking 3 load. Now paste here, paste spatial value. Now selecting these two, we can, and our load case also developed here. We had 9, 100 and 109 up to this load case. We introduced this 3 load case. And by this way, we can introduce more load case in the same format. I hope you enjoyed it. And that is all about my question and answer episode. Please do not forget to subscribe my channel and also evaluate my performance with your valuable comments. Thank you.